In this video, I'm going to solve a longest substring without repeating characters problem. So this is the array data structure problem, where the problem statement is that given a string S, you need to find the length of longest substring without repeating characters. Okay, so here is the example. It's ABC, ABC, BB. Okay, so here A is unique, B is unique, C is unique, and then comes A, which is a duplicate as the first index or the zeroth index. So that means the maximum substring that is unique so far is 3, right? So now my another unique substring is BCA because B is duplicate after that, or it could be CAB, or it could be ABC, and that's the maximum unique characters you can get, which is 3. So the output is 3. And if it's BBB, BB, that means all of these are duplicates, so the maximum is any one of these 5 letters. Similarly, then you have PWW, KEW. It's PW is unique, or WKE is unique, or KEW is unique, but all of them are 3 characters, so max is 3. It doesn't matter which one you pick. And the question doesn't care about the string itself, right? It doesn't care about the letters, it just cares about the maximum length of the unique substring. So you just need to return the number of unique letters in a substring. And the constraints for this question is the maximum length of the string could be from 0 to 5 times 10 to the power 4, and the letters in the string are English letters, could be digits, symbols, and spaces. Alright, and this is also frequently asked questions that you can see here. Microsoft, Meta, Amazon, Apple, Google, frequently asked in a lot of other companies like Uber, even Walmart Labs, IBM, ServiceNow, TikTok, etc. Now talking about the solution for this problem, first thing that would come to your head would be the brute force approach, right? Which is you take the first letter and then C traverse the string until you find the duplicate, which is this third index, right? 0, 1, 2, 3. So the max of until third is 3, and then you move your left pointer to B and you do the same again. You keep traversing until you find the duplicate. So that's for each letter you're kind of traversing until you find the duplicate. That means almost O of n square. But the space complexity is nice because you are not using any extra storage. You are just keeping a counter for the traversal and keeping a counter for the maximum length of the substring that has unique letters, so it's pretty constant. But now to improve the runtime complexity, you can use a better approach, which could be you use a hash map to track all the traversed letters, and then when you find the duplicate, then you see how many letters are there in that window between where you find the duplicate, before you find the duplicate, basically. Meaning you traverse through this one, traverse A, unique, max is 1, traverse B, you put that in a map, and the max is 2, you traverse C, there's no duplicate for C, so the max so far is 3. Then you go to A, which is duplicate as the zeroth index, so now the max so far is 3, but you move your pointer from 0, because that was the duplicate one, to B. Basically you increment your duplicate counter, right? So you can keep 2 counters basically, one as your left end of your window, and the other one is until you find the duplicate, and whatever is the difference between those two pointers could be your maximum length. Alright, so now to solve this using Java, as I said, I'm going to use a hash map first. So the hash map would be character to integer. Integer represents the index. Alright, so I'll call it unique hash map, new hash map. Alright, then I need one counter to find the max length of the substring that is unique. In the beginning it would be 0. So now I need to traverse over the string, and as I mentioned, we'll use two pointers. One is the right pointer that goes through individual letter, so it starts with 0, and I'll also use left pointer which also starts with 0. So the basically left pointer represents your left bound of the unique characters, and right pointer indicates until you find the duplicate, basically right bound of the unique characters. So you keep iterating right until the end of the string. So length, and you keep incrementing right with 1, but your left would be incremented only when you find the duplicate. Wherever you find the duplicate, you just increment your left pointer to duplicate plus 1. Alright, so that becomes your for loop. Now in general, what you do is you just put the letter to the map, which is unique map dot put let's get the letter first, which would be s.char at right pointer, because that's what we use for the traversal. And we put the letter and update with the index, which is right pointer. So now you need to check for when you find the duplicate, which is unique map dot get right pointer, and if you will get the index of the duplicate letter. I call it dup index. Alright, so now if dup index is not null, that means there is a duplicate, and if the duplicate index is within that boundary after a left index, left pointer, which means if dup index is more than or equals to my left pointer, because that's the start or beginning of your unique characters, right? If you find that duplicate within that boundary, then only you care. If not, you ignore it, because that has already been traversed and you don't care about that. So if that's the case, you need to update your left pointer. Okay, so your left pointer becomes duplicate index plus 1. Right, because you found the duplicate. Now you move your left bound. Oh, actually I need to move this up here, and I need to get the letter, not the right pointer, right, because my map is putting character to index mapping. Alright, otherwise I put the letter with the index on a map, and my maximum length I calculate to be the number of letters between left and the right bound, right, which is max equals to whichever is the max between the current max or the new number of characters between the right and the left bound, which is the right minus left plus 1. And the reason I did plus 1 is if it's A, B, C, right? If my left bound is at A, right bound is at C, the difference would be 2 minus 0. Right, but the number of characters there are 3, so I have to plus 1, which is why I'm doing plus 1 here. Alright, so that becomes my maximum length of the unique substring. And with that, at the end, when I done traversing the string, I can return my max. Alright, let me go through the solution one more time. I'm using HashMap to keep track of the indices of the letters, and max to store the number of unique letters, maximum length of unique characters. Then I have two pointers, left pointer and the right pointer, both start with 0. Right pointer goes until the end of the string with increment of 1, but the left pointer is incremented only when I find the duplicate, and I increment my left pointer with the duplicate plus 1. So now let me run it. This is a math.max. Alright, so ran with the test cases here. You can see ABC, ABC, BB has maximum of 3, and all the letters being B 5 times. Obviously the unique length is 1, and if it's WWKW, the max is KW 3 or WKE 3. So with that, let me submit the solution. Alright, and that successfully submitted with the runtime as O of n, because we are traversing the string until the end, so it's going to be O of n, and you can see that it will only take 4 milliseconds and it beats 89% of the solution submitted in LeetCode. And memory wise, it's using 44.53 megabyte. Memory is also O of n, because you can see that I'm using the hash map to store the individual element or individual character in the string, and the worst could be O of n, because I might have each letter as unique. And this is also, as I said, is O of n. This beats 57.86% of the solutions submitted in LeetCode, which is not bad. Alright, with that, we solved the problem of finding the longest substring that has the unique letters in it.